This is double replacement, and you can find this on page 13 of your packet, right? So we're just going to jump right in. Okay. All right, so if you look at this, in double replacement, what's happening is a kind of trading of partners. So it's kind of like, I like to use the analogy of a do-si-do, and I can show that to you in class if you'd like. But specifically what's going to be happening, and I kind of showed this at the very beginning of this unit, but what's going to be happening is that the positive ion of your first compound is going to be attracted to the negative ion of your second compound. All right, and what's going to be produced is either going to be a precipitate, or, as we'll see in lab, you're not going to have any precipitate form, and you're just going to have an aqueous solution. Alrighty, so let's look at a couple examples. There are two different types of double replacement reaction, but to be honest, I don't even like dividing them into two because you do the exact same thing for each type of reaction. So what you're going to do is, since the positive of one is going to combine with the negative of the other, positive of the other one is going to combine with the negative of the other. I like to call it innies and outies. So this is the outie. So the outies, so Ag and Cl are the, what I would call, the only problem with these videos, I can't show my air quotes. The outies of these compounds are Ag and Cl, and the innies are going to be K and NO3. Okay, so Ag is going to bind with Cl and K with NO3. All right, so here's the hard part. All right, I need to make a compound with Ag and Cl and K and NO3. So at this point, if you're not comfortable making ionic compounds and crossing your charges, you're in really deep water, and you really need to be coming in as soon as possible. All right. What you should realize with NO3 is that NO3 has a -1 charge. Ag has a +1 charge. So if I have a +1 and Cl has a -1, when these form a compound together, Ag has a +1, this has a -1, I'm just going to form AgCl. And I'm actually done. So that really wasn't bad. I wasn't really crossing charges. Though I was, but I didn't really have to do anything. Plus, well, K has a +1 charge, NO3 has a -1 charge, so I have KNO3. Those are my two products, and I'm done. Okay, so really not that bad. All right, let's look at another example. Remember, outies and innies, so here's my outie, and here's my innie. Okay. I am concerned with the identity of these elements, not with how many there are. All right, so I have Mg and OH that are going to be forming, and Ba and Br that are going to be forming. Okay, if I need the two, that's fine, but the only reason why I would be using the two is because I've crossed my charges. So let's look at this. I got Mg and OH. Well, Mg has a +2 charge, OH has a -1 charge, so I actually do end up forming just Mg OH2 because I crossed my charges. All right. My other product is going to be Ba and Br. Right? So barium Ba has a 2+ charge, and Br has a 1- charge, so I have BaBr2. All right. Awesome. Number 3, I'm actually going to let you guys do. So do outies and innies, all right? Make sure you're clear on what the charge of each of these elements are, okay? So pause this video right now. All right, so what you guys just did was precipitation reactions, all right? Pretty nice and easy. You just do innies and outies, and I'll explain with precipitation when you know whether you have a precipitate or not. That's what this next section, the section after this, is going to be. The other type of double replacement reaction is acid-base neutralization, which sounds really, really scary. It's actually really not. If you notice here, I've got a metal hydroxide. Remember, if I have OH at the end, I have a base. If I have an H out front, I have an acid. So here I've got a base and an acid. All right, all I'm going to do again is just my outies and my innies. So I've got Na forming with Cl and H forming with OH. All right, so Na has a +1 charge. Cl has a -1 charge. So one of my products is just going to be NaCl. Okay. My other product, if you notice, I've got H and OH. That ends up giving me 2 H's and 1 O, same thing as just H2O. So guys, neutralization reactions, which we're going to be studying next semester, all you do, you take a base and an acid, and what you end up getting is a salt, NaCl, or any ionic compound, and water. So you guys just did your first neutralization reaction. Congrats. All right, let's look at a couple more together, and then I'm going to have you guys finish off the rest by yourselves. Magnesium and NO3. Here are my outies. And my innies, H and OH. Now, remember, what matters is the identity of the element, not how many I have. So, if you notice, I have OH2. That doesn't matter. All that matters is I have OH here, and I have H here. Mg here, and NO3 here. Okay? So, I'm going to combine Mg and NO3 right now, all right? And just for your benefit, I'm going to one last time show my crossing of my charges. So magnesium has a 2+ charge, okay? NO3, nitrate, NO3 has a -1 charge. So I'm going to cross my charges, okay? And what I end up with for one of my products is just going to be Mg. Remember, since I have 2 of them, my NO3 has to be in parentheses, NO3, 2. My other product, I have H and OH. Okay, ignore that 2, that doesn't matter. Okay, that's just to that was just used to balance my charges for MgOH. So I've got H and OH, so that's going to be H2O. All right. So what I want you guys to do now, complete number 3 and number 4, do outies and innies, okay, and make your products. All right. The only challenging thing, guys, is as soon as you've completed this, you have to make sure that your that you have balanced your reaction. All right. So if I look at this right now, I have 1 magnesium, 1 magnesium. I'm going to change colors for you. Up here, I know this is balanced because I checked it already. But here I've got 1 magnesium, 1 magnesium. I've got 1 nitrogen. I've got 2 nitrogens. So I've got to put a 2 out front here. All right. Now I've got 2 oxygens here, 6 oxygens here. So I've got 8 oxygens total. All right. I've got 6 oxygens total here and 7 here. There's something funky going on here. But if you notice, for hydrogens, pause that before you do anything drastic. If you notice here, I've got 2 hydrogens plus 2 hydrogens. I've got 4 hydrogens total. So if I just put a 2 in front here, I've got 4 hydrogens, 8 oxygens, and 8 oxygens. So now I'm balanced. So when you complete 3 and 4, write your products and then make sure you're balanced, all right? And that's the end of the beginning of double replacement reactions.